let's go through the assignment because some of the people have reached out to me regarding the doubts they had for the assignments that I've gave you. So I'll go through that email line by line and uh, I'll just go through it for you guys. So what can you see on my screen? Can anybody confirm?
Yes, sir,
Yes, sir,
visible.
that's visible.
Okay, this is the assignment. Okay. So it says the goal of this assignment is to familiarize you guys with basic concepts of embedded system, including their architecture, programming, and application. Okay, you will also gain hands-on experience with a simple embedded system project. Okay, so I just want to know your level of understanding of embedded system after this session. Okay, so that I know how we are doing here. Okay, that is the main purpose of this assignment. Okay. So there is some self-study part that I have mentioned over here, okay? Although most of the things will be covered during the sessions, but few things you got to study on your own, okay? So we are gonna study few more things today. So after that, whatever is left, you're gonna study and answer these questions, okay? Depending on what you have read, okay? So so a lot of people have doubts over here that how should they send me the assignment. So basically, I mentioned over here a detailed project report with design and your source code. So basically, it's gonna be reporting sort of stuff. Okay. So you will start drafting a Word file. Okay. These five answers first, and followed by your project report, how you do reporting for the project. Okay, that is a Word file you will convert to PDF and send it out on my email. Okay. Another thing is just presentation, how you do your, project thing. You're gonna prepare a PPT for that, and that is also to be attached in the same email. Okay. So this is gonna be the whole thing. So now I expect you to speak up about your doubts so that I can clear it now itself.
Sir, I have already sent the file to you. Can you please check it
I
is
will,
in?
yeah, I've checked it. I will email you with, whatever the corrections are. I mean,
Okay,
uh,
sir.
I just clarified a few things, right? So do you think your thing is aligned with what my expectations are?
Sir, I think not properly, sir.
Yeah, yeah. So yeah, of course you have sent it before the timeline. Nobody was bothered to even ask the doubts. I'm really surprised if people are having doubts, why aren't they reaching out to me? They have my number. So what was the timeline given to you guys? What is the due date?
Sir, due is tomorrow, I guess. Sir, I had a doubt regarding, sir, that project. So, how, sir, how should we do the simple embedded system using Arduino and all that?
I
So,
mean,
do we have
you're not
to?
supposed to bring hardware, okay? Just take a simple topic, okay? Take a simple topic, learn how the system is designed, okay? Internet is your source for now, okay? You have nothing to worry about. I mean, you have nothing to worry about the source and stuff. Internet is available. You got to search some cool topics and then pick anybody or any topic out of it. Just go through it, okay? I know you're gonna pick it up from internet, but I'm fine with it. You know why? Because in the end of the day, you're getting to know how embedded system is designed, how you're at least going through the stuff, you're at least going through the topic. Okay, you are knowing if you're selecting temperature controller, then get that thing, okay? Then read through it, okay? Then list down the problems you came across while understanding the system. So, okay, I know it is available ready-made, but I want you to read it. I want you to know I mean, I want you to list down the problems faced by you during the understanding phase, okay? Then how the system is designed. what is the source code, understand the code, send me those code files, and overall, just for a representation, make a PPT. Okay, I might ask you guys to present it to me. Okay, that is one thing. Okay, so basically, I want to know what is the level of understanding that is there in your mind because you guys are new to the whole thing, right? What is the basic intention? So any doubt you guys still have? Speak up, guys. If you guys are not having any doubts, then I'm expecting you to complete in the mentioned timeline, right? I only got one assignment during this period. It is not a work of even a day. It is you can finish it up in an hour or two max. Okay, and it is for your understanding. So I expect you to complete it. Okay, what's the due date? Let me again go through it. Due is 7th. Okay, when is 7th September? Tomorrow. Hmm. Okay, let's say I extend your due for 5 more days. Okay, I expect it to be 13 now. Okay,
Okay, sir.
13 September. Hmm.
Yes.
Before 13, I expect it from everybody. Okay, so this is about assignment work, and so I still see very less people have joined. Mm. Anyways, we're gonna start now, not waiting for anyone. Okay.
So,
Yes.
sir, in this you have mentioned that you have to means submit the source code file also. So means so in the semester, so we will have to learn when we have to study the codes also. That means like the languages and all that.
So see, Prathamesh, what is embedded system? Okay, a system which is designed to do certain tasks. Okay, how it is doing that task with the help of controller, and how is the controller able to tell other components of the system what is to be done with the help of the code, right? So we need the code, and embedded codes are different. That's why I want you to go through it. And you have one unit in this embedded security syllabus, software security. In that you will need to analyze a lot of codes, and I mean embedded codes. Okay, embedded codes are different than our regular code that we use for application development. Okay, so embedded codes are cool, different. Okay, those will be small codes, okay? Those are not huge codes. Just go through the files, okay?
Yes, sir.
Yeah, and anytime you have doubt, you can reach out to me, guys. You have my number. Yeah. So, anything else you wanna ask about this assignment? Okay, fine. I take it as no. I stop my screen share. I'll share another screen. So before we actually begin with our today's topic, I would like to revise whatever we've seen till date because it's been like almost a couple of weeks, right? And I want to just brush up and to touch base on those things again so that we are not lost anywhere. What can you see on my screen, guys?
Sir, what is an embedded system? That screen.
Okay, okay, cool. So, anyone want to tell me what is their understanding of embedded system? बताओ तुम्हें तुम्हें क्या लगता है embedded system क्या है? For like whatever the discussion we've had till now, depending on that, tell me कि embedded system क्या है and मतलब according to you, what is embedded system? Just want to know that. Anyone?
Sir, it is a combination of hardware and software which is designed to do a certain task.
Right, exactly. Okay. So there is some hardware, okay? There is some software part, okay? Which are working together to achieve certain tasks, okay? It is nothing but embedded system. Hmm. This is the bookish definition. An embedded system is an electronic product that contains microprocessor, one or more it could be, and software to perform some constitute function within a large entity. Okay, this word is important. Okay, why this word is important? Because there is some system. Okay, let's say this is a car. Okay, we have many embedded systems in car, and that's why these systems, where are these placed? In a large entity, which is car in this case. Okay, that's why this word is important. So these are the examples we discussed. Okay, this is traffic collision and some avoidance, yeah, traffic and collision avoidance systems. Then there is CNS, which is, I guess, communication, networking, and surveillance, something like that. Then in-flight entertainment. So all these are what? These are embedded systems, right? Within large entity. And what is the entity in this case? This aircraft. Okay. So can you come up with some more examples we discussed last time? Come on, at least a couple of more I expect. Or give me examples of embedded system, guys.
remote washing machine,
Okay, washing machine, good.
The smart TVs.
Smart TVs, okay. What else? You talked about smart TVs. I will write smart speakers. And what are smart speakers? What is mean by smart speakers?
Sir, like Alexa.
Alexa, exactly, Alexa. Anything else? Microwave oven, okay. Mostly kitchen appliances, okay, that controls thing, okay. Then there is controller in your fridge also, okay.
Sir, can Siri be the part of embedded system?
See, Siri, what is Siri? Siri is a software, right, in your phone, right? So if they come up with something like Alexa, Siri wala speaker, then definitely that is an embedded system. So Alexa we are considering as embedded because there is प्रॉपर डिवाइस लाइक स्मॉल डिवाइस छोटू सा डिवाइस है जो किधर भी रख सकते हैं ओके नाउ देयर इज अ पार्ट like what we are seeing is it is a part of a operating system that comes with okay a tool so that is different So anything else? Last example, we move on after this.
Smartphones.
Smartphones, okay. But in this case, smartphone is a large entity, okay. And inside smartphone, we have a lot of systems like this. I mean, there is a GPS, there is Bluetooth, there is touch screen panel, okay. So all these are embedded systems in smartphone, okay.
Sir,
Okay,
medical
so let's
devices.
medical devices, right? Like what? Pacemaker, okay? This is
Hmm.
a fantastic example. Pacemaker,
Sir, then robots which are in factories, can be they included in embedded
robot.
system?
Yeah, there are a lot of embedded system in robotics. You're right.
Sir, also the treadmill.
Yeah, there are multiple systems. Yeah, treadmill that can be considered for sure. Then this show is getting excited. Okay. So then what else we got here? ATM machines, guys. Then we have point of sale devices, okay, where where you use your credit cards,
So traffic
the
lights.
machine. Yeah, that correct. Traffic control rights. So whatever system we have written on this board today, each and everything you will see as an example in as and how we go on with our syllabus. So you should be aware. That's why I'm bringing it out. So yeah, uh, next what we studied was embedded secure. Yeah, again example only. So basic security definition. I don't think we need this. Okay. So embedded security trends we've studied. Then what are embedded security trends nowadays? Like complexity has become one of the major trend in embedded system. Okay, because demands for features is increasing, okay? And many of the problem relating to, loss in quality, safety, and security in electronic product can be attributed to the growth of complexity that cannot be effectively managed, okay? Linear growth in hardware and software content creates far more than linear growth in overall complexity due to an exponential increase in interconnection between functions and components, okay? So what these two lines are saying is that a growth in hardware and software has far more than linear growth in overall complexity. Okay, there is growth in complexity as well because of all the inventions that we are doing nowadays. Okay, um, because of what? Because of exponential increase in functions and components involved in embedded systems. Okay, and many problems relating to quality and safety and security in electronic product can be attributed to the growth of complexity that is not effectively managed. Okay, so इधर हमने example भी देखा था कि if you are designing a temperature controller, you have two ways. Okay, you can simply have a simple system. Okay, wherein you just have a temperature sensor, then a controller, then a fan and heater to maintain particular temperature. And the same system can be designed other way also, okay, where you have a fancy display, okay. There is UI design, okay. Then you have uh, some expensive hardware and complexity, of this system is of course more than this, right? Then you can also what you can also implement here is that in if you got to implement it using some fancy methodologies, what you can do is you can give mobile connectivity to it. Of course, you will do that if you got to add features. Okay, remote connectivity for controlling purpose. So what is the difference between these two systems? This is a standalone system which is just doing its task and happy. Okay, what this system has now, it has lot of features. Okay, so developer got to take care of lot more features than the simple system. And what it has done, it has increased complexity, right? And thereby increasing the surface for malicious actor to dance upon, right? So this is the point I'm trying to make, guys. Simpler is your system, better from security perspective. Okay, the more it gets complex, it is hard to manage the complexities from security perspective. Got my point?
Yes, sir.
So this is thank you. So this is just basic example of how systems are getting complicated. What is this? This is you know grid system here. Okay, wherein home we have smart meter, then there is home gateway, then appliances which are having connectivity this with this smart meter. Okay, then we have home area network over here, hmm, which is establishing connection with our smart meter. Okay, then that is connected to a substation. Okay, again there is some wireless connectivity. So how many connections? See, so there are uh, you know there's a lot of scope for anybody who wants to get inside of this system and break it and do something that is non-compliant or that is not in interest of anybody of us. So there is a lot of scope here. The point I'm trying to make is complexity. Complexity increases, security decreases. This is our first principle. Okay. तो एम्बेडेड लिनक्स का केस स्टडी देखा था हमने जिसमें we just went through real time facts wherein like how embedded Linux became popular and people started relying on embedded Linux actually even though it had a lot of you know vulnerabilities that were discovered later. Okay, and you can see the numbers. So even though like makers of this software and those who maintain this later, they mention clearly that this software is not definitely not designed to be relied, upon for complex infrastructures and you know critical infra basically. But still, the use of embedded Linux got very popular because of its open source nature and accessibility. And later on the vulnerabilities were discovered and they've been tackled, but still uh, vulnerabilities do exist and teams constantly work on those vulnerabilities. The next trend we studied was network connectivity. Okay, so what it says is traditionally been thought as standalone system immune to the risk of internet. Okay, embedded systems were never meant to be connected to internet, never meant for internet. But later, with the advent of internet and with growth of our demands, this was added to the embedded system, and that's why we are studying this subject. Okay, for security, because if it was standalone, then only hardware security we would have been considered about. That you will learn in next unit how is achieved. Okay. So remote management is the main reason behind having networked embedded systems in place. Okay. Then General Motor का एक छोटू सा case study है, okay, which I removed because anyways this is I mean very old thing, so but good one because they had introduced some car door locks, okay, for remote management from smartphone, and that was a very first time it was done, and then there was some problem. Uh, so there are a couple of things that will come to you as your next assignment, which is this and this General Motor ka case study. So this you will research from internet and let me know. Okay, a short report. I'll send you the details after this lecture, but so that two assignments. Then third trend, okay, has become like reliance on embedded systems for critical infra, okay. And then we have seen some critical infra that we rely on embedded systems for, okay. So smart grid is of course one example we just studied. Then in transportation systems, we have uh, planes, trains, elevators, and industrial vehicles, okay. Everything, everything mentioned over. Can someone admit the next guy that is joining in? I just heard the voice. Then, then we studied some financial infrastructures like bank, credit card processors, then medical devices. So all these are what critical systems. So this has been seen in the uh, trend. Then again, sophisticated attackers. Okay. This Stuxnet, I gave you, I mean, I'm gonna give this to you as an assignment, but at least submit me first one before that. So this is one of the sophisticated attack in history of embedded world. Then we just went through the types and applications, okay, and types, of course, where we've seen types depending on the uh, two major parameter, where it's functional and what is microcontroller performance. Okay, functional requirements. So these are the types: standalone, real time, network, mobile, soft and hard real time. Okay, so I want each one of you to talk about one type each. Okay, so who is talking about standalone? How we categorize and few example of standalone embedded systems. Who will tell
Ex
me what is stand?
Excuse me, sir.
Yeah. Yes, please
Sir,
go
are
on.
you presenting which slide? Because we only see the what is an embedded system slide. Only the first
Oh,
slide
you.
we can see.
Oh shit, man. You guys, they should tell me, right? I was. Oh God. Okay, so you only see what is embedded system page. That's all you see.
Sir, till now, it means just for last 5 seconds it was visible. Thing.
You should speak up. That's the reason I've been, telling you speak up, speak up, speak up. Anyways, thanks for the Prathamesh. Okay. Uh, now do you see my screen, properly?
Yes, sir.
Now is it changing?
Mm, no, sir. So
Sir,
it's
it is
still
still
on
embedded system.
what is an embedded system.
Mm, Okay, let me.
Sir, it has changed. The next slide you choose, it was changed.
Okay. The only thing I can do is now to share the entire screen, which I of course didn't want, but anyways, I'm doing that. Uh, Now you should not face any problem. What do you see on my screen now?
Yes, sir.
The screen on
Yes,
which we
sir,
have
the
the
plain screen, plain one.
Okay, good. Now do you see it moving?
Yes, sir.
See,
Yes,
yeah,
sir,
there
now
are
it
so
can
many
move.
things I had written, and I thought you guys are looking at it. Oh, so you should
No, sir,
let
we
me.
actually thought you are just picking up about the things and explaining us to it.
Okay, okay, fine. So, anyways, so this is the page when I talked about the simple temperature controller and the fancy design, and I have written it actually in the board. Okay, anyways, so gridding system, smart grid, then network connectivity, critical infras, and sophisticated attackers. Now common types. Okay, so we were here, standalone. Who is going to talk about standalone system with one example?
So can you give a basic overview?
Standalone. Okay, so anyways, we studied it in the last lecture. So these are the types depending on, depending on functional requirement. Okay, standalone. What is the meaning of word standalone? It is working on its own. Okay, without any support from external network or external infra. Okay, so it is the system that is not connected to network. It is on its own. Okay, that's the word standalone means. Okay, so basic example of standalone system is basic MP3 players. You can say uh, basic embedded system like say microwave oven. Okay, it just has standalone
Sir,
system. It is
FM
on
radio maybe?
FM radio. Yeah, but that still has some radio connections. But yeah, that could be a network, na? Network system, right? It has network involvement. Standalone is completely on its own. Okay, understand that. Then the basic temperature measurement system that is standalone embedded system, right? Anything that is not networked and electronic, it's standalone embedded system. Okay. Then we talked about real-time embedded system. So what is real time? Of course, we need response in real time from such systems. Okay, and then there are two categories: soft and hard real time. Sorry for that. So soft and hard real time is, what does that mean? Anybody? Do you guys remember soft real time, hard real time?
So
Real-time OS system that
Real
mobiles
time,
have, smart devices have, real-time OS.
real time response. Okay, very prompt real time response is required, like in medical device, right? So can you now talk about soft and hard real time?
sir, in soft real time, a minute delay is negligible, means we can uh,
Yeah, correct. and hard real time. No
Uh,
delay is tolerable, right?
yeah.
No sort of delay is tolerable, like in medical devices mostly. Okay, then network in network, what all will come under network systems? Now simple. Now
Routers,
talk about FM
servers,
radio. Yeah, what were you saying?
routers and servers.
You are not audible properly, or is it only me who is not able to hear you clearly? Could you
Sir,
please?
routers and servers.
Oh, okay, fine. Yeah, good one. So, server is an entirely different thing now. Okay, we are going to different space, but yeah, that is not one of the example. Okay, a server might have certain systems under it. Okay, those are embedded, but server cannot be considered as embedded system. Routers, yes, I will definitely call it. Then FM radio, as you told. Then mo now talk about mobile embedded systems.
iPad, tablets.
Yeah, but is tablet an embedded system? Tell me.
Sir, it also performs it has a screen, right? Then
Yeah, so uh, I'll tell you. So there are certain parts of the tablets. Okay, if you split it, that is a touch screen panel. Okay, touch panel. Then there could be some communication circuitry in that. Okay, communication thing. So these are embedded systems in this tablet. Okay, it is a split example. GPS navigation. Then there must be a Bluetooth transceiver, right? So these are basic examples. Okay, depending on functional requirement. Okay, we are just revising it. We just went through it, and now we have microcontroller performance. So we spent a lot of time on these types, guys. So anyone remember small scale, medium scale, sophisticated? How this is classified depending on microcontroller का performance? किसी को भी आ रहा हो तो बताओ. We talked a lot about microcontrollers over here. Okay, I'll give you small hint. Okay. Small scale, it has something to do with how microcontroller operates. Still no. Okay. So do you guys remember now? Hmm?
So it depends on clock cycles number.
It depends on how many bits the controller is processing in one clock cycle. I mean, we say na कि this is the 8-bit microcontroller, hmm, the 16-bit microcontroller. So what does that mean? We've seen in last lecture, which is exactly what you pointed out. These are the number of bits that are getting processed in one clock cycle. Okay. So nobody asked me what is clock cycle then. Or you guys are aware of it? Hmm. I guess I have shown this also in the last lecture. Anyway, so all these are digital devices, right? They work on some signal, okay? Digital signal. What is this? This is one clock cycle, okay? So these are the signals that a microcontroller work upon, okay? There is a quartz crystal. Okay, if you go through the basic microcontroller, diagram, you will realize something like this, okay? Connected with capacitors, okay? And grounded properly. Not exactly, but okay, it's like this. Okay, wait. Okay, anyways, I'll draw it here again. So, just for your understanding. Okay, now you're gonna study that assignment in your project, right? So you will go through multiple diagrams. So I'm just gonna explain you clock cycle shortly and how you will find the circuits of microcontroller. Okay, so this is basically the crystal, okay, which is generating cycles. Quartz crystal this is, and this is uh, these are capacitors. Okay, this is grounding. So there are two pins in your microcontroller. Okay, that require this signal to be there constantly, which is this signal. Okay, and how many bits does your microcontroller process in this one cycle is the capacity of your microcontroller. Okay. So if this is processing only 8 bits, then this is 8-bit microcontroller. Okay. If it's processing 16 bits, it is 16-bit microcontroller. So tell me what parameter uh, what parameter I'm talking about here? Number of bits being processed means what is getting affected with respect to its operation. Okay, so we are talking about speed of operation of our controller. Got my point? Is this clear, guys? This is very basic.
Yes, sir.
Okay, thanks for confirming. So now you must अभी तुम्हें थोड़ा याद आ रहा होगा जो हमने पढ़ा था लास्ट लेक्चर में ये स्मॉल स्केल मतलब 8 बिट 16 बिट याद आ रहा है ये
हाँ सर.
ओके गुड 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 सो स्मॉल स्केल में this is the classification based on performance. Okay, तो small scale में of course थोड़े uh, छोटे प्रोसेसर्स होंगे राइट जो बस 8 बिट 16 बिट प्रोसेस कर रहे हैं राइट देन ओके design using 8-bit or 16-bit microcontroller, okay, then can be powered by battery. The processor has very little memory resources. Now we also talked about something like memory and data. Now, can anyone tell me what I told you in the last lecture about it? Data memory and program memory.
Sir, they are basically RAM and ROM.
Exactly. Which is RAM and which is ROM out of these two?
So I guess program memory is RAM and data memory is ROM.
You're right. You're right. You understanding, right? So whenever I say program memory and data memory, you know what I'm talking about now. So these are the example of small scale systems, temperature monitoring, simple displays, okay, basic input output operations. Mostly simple dash systems. Dash is again data acquisition systems, okay? So comes under small scale only. Then medium scale, okay? मीडियम स्केल में ठीक है प्रोसेसर की कैपेसिटी बढ़ गई थोड़ी नंबर ऑफ बिट्स इट्स प्रोसेसिंग इज has gone to 32 bits. Of course, then it's faster but complex. So so एक एग्जांपल हमने देखा था पहले in trends in embedded system की how complexity has become a trend and with demand in feature complexity increases, right? So this is the very best example. What I have mentioned here is these systems are designed using 16 or 32-bit microcontroller. So demand for speed has increased, right? What has it increased in parallel? It's complexity. Are you understanding the point I'm trying to make?
Yes, sir.
Used to perform, thank you so much. Used to perform more complex function, of course. So DSP, data storage, and UI control, like more complex and operation that requires speed, okay? Basically, speed is the hero here. Everything is about speed here and capacity. Because DSP, have you guys studied DSP subject in your engineering? No, right? So uh, this is one of the very interesting subject, okay, in electronics. So डीएसपी ना डीएसपी के अलग किट्स आते हैं प्रोसेसर्स अलग होते हैं डीएसपी के क्योंकि दो signal require higher level of processors that can process such kind of data, okay? So ये mostly 16 or 32 bit processors होते हैं ठीक है again sophisticated same but this works on multiple algorithms and complex hardware and software components so they require a lot of memory to perform. Okay, memory means RAM. Okay, the memory requirement depends upon the application. Okay, may require anywhere from few MBs to several GBs of memory. Okay, example using devices that require complex computations like robotics, autonomous vehicles, and advanced medical equipment. So this is about sophisticated embedded system. So not necessary only 32 इससे भी ज़्यादा के processors available है okay controllers. So understood till here?
Sir,
Yes, please tell me.
sir, how quartz crystal produces clock cycles?
So see, crystals are of two types. Okay, crystal is it produces the what cycles depending on the crystal का ना कि ये rating होता है. Depending on that, it produces cycle. Crystal is something that is generating this on its own. It doesn't require anything. It is there is some component, okay? These are naturally found crystals actually, but those are converted to electronic later, okay? When we connect it with the capacitor configuration that like I have shown you earlier, it generates the clock cycle because of the two capacitors that we have connected in series, sorry, in parallel to each other along with the crystal. So you will study that in hardware unit, okay? Not the crystal physics, but we will more move into, in the architectural part of the controller and how can we securely handle it.
Okay, sir.
Yeah. The basic operation of Crystal is that. So anything else? Because this is what we've studied so far, and we are going to basic block diagram and what else we have. Difference between controller and processor. Then what is RTOS and such things like in a few more slides after this. So I think we should take a small break after this for let's say 5-10 minutes, okay, and then come back. Okay, I'll be here itself. Just let me know once you guys are back at your desk. The screen share has become very complicated. I don't know what's the problem. Okay, I am not taking much of it in. We'll go for the break. We'll be back in 5 minutes. Hey, you guys, you back? So, uh, if you're there, just wave at me or let me know by some means that you're here so that we can start with today's points. Okay, Kunal is here. Prathamesh, Digvijay, Shubham. Okay, let's wait a couple of more minutes. These guys are still not here. So what do you see on the screen, guys? Let me adjust the slide first. So do
So
you
we
see
can,
whiteboard?
yes, sir.
Okay, cool. So now what we're gonna study is, okay, basic things we're gonna study, like what all is the part of embedded system. When I say embedded system repeatedly, so uh, so this on this whiteboard, guys, you can also join and write if you know. Okay, this is that kind of whiteboard. I'm not sharing my screen. I just started whiteboard. Okay, so there is processor. Oh, it has become way too fancy. Anyways, so processors, then we have, let me quickly do this first. Pointer. Then we have program memory. Okay. Then here we have data memory. Then interrupt counter. Here timer counter and interrupt counter. Okay. Then parallel ports and serial ports. Hmm. Okay, this is the basic structure. Very basic. Okay, what happens inside of an embedded system. Okay, then from externally, what we give power supply. Power supply, then input devices, interfacing devices, driver circuits, etc. Okay, input devices or interfacing. Okay, then there are some application circuits. Then we also have output devices. Okay, so I'll explain you about each part of it. So, but this is how an embedded system looks like. Okay, in short. So, processor, our hero. What idea do you have about it? Anyone can anyone speak about it? Talk about it basically. What is processor? Okay, so processor is nothing but something which is controlling everything, okay, which is processing everything, which is processing the data coming in, data going out, okay, which is the bridge between all of this, which is the heart of the system, okay, right? So what happens to this processor? I mean, we have studied how we select this component, okay, in the processor, I mean controller performance parameter we have seen. Depending on application, we go for the kind of processor we want to work with. Okay, so that depends on the application. Okay, so processor thing, I assume you have idea about because it's a very basic thing in our computers also, laptops. Then comes timer and counter. Okay, so do you have? I mean, can you think of something? आप मतलब क्या आपके दिमाग में आ रहा है जब मैं बता रहा हूँ कि एक एम्बेडेड सिस्टम में या फिर प्रोसेसर में कंट्रोलर में ओके टाइमर और काउंटर होता है व्हाट डू आई मीन बाय दिस आई मीन क्यों होना चाहिए टाइमर क्यों चाहिए टाइमर काउंटर व्हाई इज इट रिक्वायर्ड
Sir,
एनी
to
वाइल्ड गेस
count the processes, or you can say how much processes are means completed in means a particular amount of time and all that.
या in short, okay. So timer and counter comes really handy, okay, when we are doing certain applications which are time sensitive or which are, certain parameters sensitive. Like, I'll give you one example, okay. So, uh, suppose there is an application, okay. There is an application which wants me basically to toggle an LED every couple of seconds. Okay, every couple of seconds I'm saying, or every 1 second. So how will I achieve that using a microcontroller? So that is when timer and counters come into picture. Okay, so it depends on what is the frequency the controller is operating at. We have to do certain calculations and we have to feed that value in the timer. Okay. So there are huge calculations that we got to conduct before we give that value to the timer in the controller. Okay. For that second, that number of seconds. Because time is the function of frequency. You know that relation, right? Time and frequency. So it is somehow related to that. Okay. Understand like this. The timer and counter is very important thing in any controller for that say, okay. Then there is interrupt counter. Now what is interrupt? Anyone has any idea? I'll tell you, okay. I know you have no idea, that's why I'm telling you.
Sir,
But
to break the cycles.
break the cycle, let's say interrupt will act as an event, okay. Are you getting my point? Means I can configure my system such a way that means I can write an interrupt code. Okay. It is called interrupt service routine, ISR. Okay. To initialize the interrupt in controller, I can initialize in the code. Okay. Interrupt service routine. Okay. To maybe calculate the number of cycles happening, whatever could be it. Okay. Whatever interrupt could be. And once that is completed, then do this. Once this is done, do that. Or once you get this signal, then do this. Are you getting my point? Okay. Once you see rest of the guys' videos turning on, okay, stop complaining. This is interrupt to me. Okay. Got it. So it's like that. This is just a small example. Also, I can configure a key outside. Okay. Suppose, suppose this is a controller. Okay. And this is an output LED. Okay. This is an output LED connected at one of the output port. So and I have a switch connected over here. Okay. So what I'm saying is whenever you detect some signal at this port, turn this LED on basically. Okay. Turn this LED on detecting signal at this port. Okay. This is our microcontroller. So what are we doing here? Okay. Meantime, the controller will keep doing its job. Okay. The controller will keep doing its job. Okay. Another example, let's say this is a temperature controller. Okay. So it will keep working as a temperature controller, but I have set a interrupt कि अगर किसी ने ये बटन दबा दिया तो ये एलईडी चालू कर दे या फिर किसी ने इमरजेंसी बटन दबाया तो इधर अलार्म चालू कर दे. So what is this interrupt? Are you understanding literal world of meaning of this word interrupt? If processor will, I mean the controller का ये जो कोड है ना वो कोड line by line execute होता रहेगा. Okay, we have initialized our ISR. Okay, means interrupt service routine, and controller will keep performing its routing action because interrupt service routine is in the back of its mind is trying to fetch and interrupt. It is not polling for that. Polling means it is not checking continuously, but it is an event driven thing, right? It is an event. In what is interrupt? Interrupt is an event. So whenever that event will happen, certain action has to be taken place. So after the event has occurred, then probably might the normal operation halts and it goes to interrupt service routine and sees what I have to do now. This event has occurred, now what I have to do. So this is what interrupt is for. Are you understanding the applications? I mean, are you thinking, keeping applications in your mind? मैंने दो चार एग्जांपल आपको दिए, राइट? कि ये किस लिए होता है, क्या क्या कर सकते हैं हम इससे. So that is why interrupt counter is important here. Then program memory, data memory. Do I need to explain this to you guys? Are you guys gonna explain me? Program memory, data memory. Come on, fast. Anyone?
Sir, the means like the memory required to run the programs means the applications in real time. So program memory or RAM is required. But to store the data and fetch it later, so data memory is required. Means like to store the
Okay,
something and
got it.
after.
Yeah. So this is nothing but program memory, data memory. Okay, very basic thing. Huh? And then there are buses. Okay, data bus is there, address bus is there. There are two buses, primary address bus and data bus. Okay, data flows through data bus, address flows through address bus. Now there are memories in our controller, right? So that memory location is nothing but address. What flows through address bus. Okay, so memory will look something like this. Okay, just for your understanding. I want to store data here only. Okay, so address of this location will travel through what? Address bus. Okay, data will flow through what? Data bus. So this is data bus, address bus. Basically, clear? Then we have a parallel port and serial port. Do you understand difference between parallel and serial first of all? Uh, I'll clarify anyways. So certain operation is handled parallelly. Means suppose 8-bit controller has two parallel ports. Okay, this is first port and this is second port. Then what do I mean? So these ports will require parallel data, right? Means all 8 pins of this microcontroller will act as an input bit and they take input simultaneously. Okay, they process 8 bits simultaneously. Okay, this is parallel. Serial is what? Only one port will be there. And data will be fed serially. This is parallel serial. Clear? So that's why parallel ports and serial ports. Hmm. Then power supply. Of course, we need power supply. Depending on the requirement of our controller, power supply is needed. Then input devices. Okay, now in our basic temperature sensor, what are input devices? Temperature sensor is an input device. In humidity control, humidity sensor is input device. Okay, anything that is fetching me data, that is input device. Output is what? What action I am taking. In say temperature controller, I have a fan, I have a heater as an output device, or maybe simple LED in this case. Okay, I have attached simple LED here, which is acting as an output device. Okay, in this circuit. So this is input output device. I need not explain you. And basic application circuit. What is application circuits? It depends like on your particular application. If you need some other circuitry, it depends on that. So this is basically our very messy components of block diagram or whatever you say it of embedded system or controller for that sake. Are you clear with this?
Yes, sir.
Now you have basic idea ना अभी दिमाग में आ रहा है ना कि अच्छा ऐसे ऐसे होता है इस सब में तभी ये काम कर रहा है अभी डॉट्स कनेक्ट हो रहे हैं दिमाग में
Yes, sir.
yeah I take it as yes only if nobody says anything so I what do I do तो अभी तुम लोगों को सवाल नहीं आया मैंने बहुत बार मैंने बोला माइक्रो प्रोसेसर एंड माइक्रो कंट्रोलर ये क्या हो गया ओके microprocessor mu p and microcontroller mu c so सोचा नहीं तुम लोगों ने मैं कभी प्रोसेसर बोलता हूँ मैं कभी कंट्रोलर बोलता हूँ तो ये दोनों में क्या डिफरेंस है और यू गाइस अवेयर तो
हाँ
मेरे
सर,
को एक बात बताओ हाँ प्लीज प्लीज
sir,
कंटिन्यू
microcontroller is like a small CPU like thing, and a microprocessor is uh just the to process the things. It means it has only one task, and microcontroller is like a CPU that performs many tasks like that.
नो you are there I mean you got the context but you simply basically interchanged okay not literally but yes somehow you did okay so when I say microprocessor the broad range of applications including personal computers servers and workstations that comes in play okay but when I say microcontroller it is designed for dedicated tasks within embedded systems okay it's like tailored for control oriented applications basically. Okay. So I would say अरे यार ये क्या भाषा है? Okay. So broad level of applications like our laptops means computers basically. Okay. And इधर क्या है? इधर very specific scope है. Correct. Of applications. Okay. And mostly designed for embedded systems only to do certain tasks. Okay. And इधर होता क्या है ना, माइक्रो प्रोसेसर में क्या होता है, वी हैव बेसिक प्रोसेसर इन प्लेस, बट लाइक external, like program memory, data memory needs to be connected externally. सीपीयू में होता है ना अपना रैम रोम, राइट?
Sir, sir, are you writing something because it's not visible?
ओ यू नॉट सीइंग इट?
Yeah.
So since how long have you not been seeing it? Anything?
Sir, yeah, sir. No, sir, just now, sir, these differences we were not able to see. Now
तो
it's
वो
visible.
दिखा था ना मैंने जो कचरा किया था पहली वाली
हाँ
स्क्रीन
हाँ
पे?
सर, वो था, अभी कहीं नहीं दिखा सर।
ठीक है, आई गॉट स्कैर्ड। एनीवेज, तो या माइक्रो प्रोसेसर एंड माइक्रो कंट्रोलर, ओके, म्यू पी म्यू सी शॉर्टकट। सो प्रोग्राम एंड डेटा मेमोरी प्रोसेसर में हमें एक्सटर्नली कनेक्ट करते हैं हम, ठीक है? अपने सीपीयू, अपने लैपटॉप में क्या होता है, प्रोसेसर होता है, इंटेल है, एएमडी, जो भी कॉन्फ़िगरेशन है, यू गाइस नो, ओके? उसमें होता क्या है, रैम रोम बाहर से कनेक्ट करते हैं हम, राइट? दैट इज माइक्रो प्रोसेसर, ओके। कंट्रोलर में क्या होता है, अभी क्या देखा हमने, कि इनबिल्ट होता है ये सब, इनबिल्ट प्रोग्राम एंड डेटा मेमोरी, ओके। तो प्रोसेसिंग पावर, अभी अभी ये चीज मुझे तुम लोगों से चाहिए, प्रोसेसिंग पावर किस में ज्यादा है, इसमें या इसमें? थोड़ा सोचो और बताओ मुझे, प्रोसेसिंग पावर किस में ज्यादा होगी?
सर माइक्रो प्रोसेसर में।
ऑफ कोर्स, राइट। एंड व्हाई डू यू थिंक?
सर क्योंकि एक्सटर्नल प्रोग्राम मेमोरी और डेटा मेमोरी है, तो फिर इंक्रीज या डिक्रीज कर सकते हैं, तो मतलब।
यस, बिकॉज देखो, on the larger scale, microprocessor is designed to handle multitasking. It is designed to handle lot of tasks, right? Lot of things are happening. General purpose computer, पूरे server run कर रहे हैं उस पे, of course. तो it has capability in gigahertz, right? And wherein our microcontroller are, less, having less processing power in bits. It processes data in like very few number of bits, okay? Even our microprocessor में भी तुमने देखा होगा, processor is 32 bit, 62 bit, 62, right? You must have heard these things, these terminologies. So it's related to the speed only. But microcontrollers in general are designed to handle a very small task, like temperature controller, like humidity, like अगर कोई सिस्टम है तो उसमें उसमें क्या कर रहा है, वो छोटा सा टास्क कर रहा है परफॉर्म, राइट? सो उसको इतना जरूरत ही नहीं है, इसलिए it is having very less processing power, I'm saying, okay? Not I am saying, it is the fact. So next thing I'm gonna explain you is applications, like so systems where complex processing tasks are required, such as desktop computers, laptop servers. We use microprocessor, okay? Home appliances, then automotive control, then industrial automation, washing machine, AC, everywhere microcontroller is used, okay? Now cost, a very common thing here, guys. I need this from you. Cost किसकी ज्यादा होगी, इसकी या इसकी? Which of these two is having higher cost?
माइक्रो प्रोसेसर।
Yes. Rest of the guys are here on the call or no? I don't know anything about you three, three of you. Like you don't have your cameras on, you're not talking. I don't understand if you're there in the lecture.
Sir,
Anyways,
actually, I just came home. I was traveling it, so I just came home. I was on the
oh,
call
okay,
already.
okay, fine. So, next topic for the day. Okay, tell me if you are still seeing my screen. What have I written on screen?
RTOS.
Okay, RTOS. Okay, means you're seeing my screen. Okay, this is nothing but real time operating system. Have you heard of it anytime?
No, sir.
Okay, so yeah, that's why we are studying it here. So RTOS is a very popular and very common operating system used with embedded systems. Okay, so you will ask me why RTOS, why not other, right? So basically, that is why we are studying RTOS for here. Okay, so it's a real-time operating system. Okay, it is designed to provide deterministic and predictable response times for task execution. Okay, deterministic and predictive. These two words are having a higher weight. Okay, deterministic and predictive. Because of its deterministic and predictive nature, it has been a trusted operating system since years in life critical appliances. Okay, because it is deterministic and predictive, right? The time response is basically very fast, and I mean, you can say RTOS is a hard real-time operating system. Okay, hard real-time, soft real-time, that is classification of embedded system. But I'm relating these two terms just to give you relevant standpoint. Okay, कि अगर hard real time जो होगा ना, so that is that in that system RTOS will be used because this is the main purpose of this operating system. It is very deterministic. It is very fast time response. Okay, these are two major things here. So its predict response is always predictable because we know this system. Okay, it ensures that tasks are executed within the guaranteed time frame. Okay, I'm just writing a few things here. So priority handling and predictable response. So we can give guarantee of this system. We can predict that this is gonna perform certain task in certain time frame. Just a second. I'm switching off my video. There's some cleaning work going on here for 5 minutes or so. So predictable response. Okay, and uh, priority handling. So what do I mean by priority handling over here? Okay, it manages the tasks based on priority levels to meet the deadlines. Okay, we set the priority level. Okay, we set the priority level, and depending on that, it understands which task is having what priority and when to handle that. Okay, so depending on priority, it handles the task. So it is that kind of operating system. It shows smart behavior. Okay. So, mm, okay. Now, so what could be difference in general purpose operating system and RTOS? Okay. So general purpose, the OS are, designed for multitasking and maximizing resource utilization, right? Designed for, of course, multitasking. हम Windows PC पे or any operating system multitasking करते हैं, right? And resource utilization के लिए ये designed है mostly. Okay. Windows, Linux, and RTOS किस लिए फोकस क्या है RTOS का फोकस ऑन रियल टाइम कंस्ट्रेंट एंड प्रेडिक्टेबल परफॉर्मेंस ओके रियल टाइम ओके एंड प्रेडिक्टेबल परफॉर्मेंस ओके RTOS के नाम है दो एग्जांपल दूंगा मैं फ्री RTOS करके एक है एंड एक VX वर्क काफी पुरानी है तो ओके सो अभी टॉपिक निकला है जनरल पर्पस ओएस का एंड प्रैक्टिकल यूज का तो आई वुड लाइक टू आस्क यू लाइक if you are to host a web app or something okay uh, for your own application what will be your preference Windows or Linux which OS if you are to own your own infra okay so what OS will you prefer Windows or Linux and why
Sir, we have to do what?
suppose you own a company okay you own a web app have your own application you have to now make it live you have to deploy it on some infra okay so what is your choice of infra and like on Windows OS or Linux what will you choose and why
Sir, I will mostly use Linux.
and why is that
Sir, security, first thing.
security so you mean Windows is not secure
Sir, but Linux is more secure than
why
Windows.
why would you say that, and why is that your perception? Of course, the perception has grown through the years due to the things that you've been, hearing all around. But why is that? So I want to dig this further a bit. So basically, so whenever you know, majority of the systems are on Linux nowadays, okay? And there are clients who still prefer Windows. Okay, I myself work for Microsoft, so I know what is the current situation in Windows. Uh, Even Windows system have improved over a period of time, but Linux has been there since very beginning. Okay, so I'll put it this way. Suppose I have a Windows server and I have a Linux server. So earlier system used to be on-prem, right? Back then also Linux existed, now also Linux exists. But on cloud and on-prem, there is huge difference, okay? So back then, what used to happen is that Windows, suppose there is a Windows server and there is a Linux server. Same web app is hosted on both of it. Just a second. God, my house help. I told her to knock on the door. She just said, okay, anyway. So What I was saying is that Windows and Linux. So both of them existed since very early. Okay, but back then infra used to be on-prem. Okay, so same if same web app is hosted in both of these using both of these systems, difference used to be like a Linux server could go without a reboot for longer time. Okay, even after installing patches on that system. Okay, but a Windows server would require a reboot every now and then. I have seen it for myself. Okay, I used to work on Skype for Business earlier. Skype for Business. Do you guys know Skype? You must have heard Skype, right?
Yes, sir.
Skype. So, Skype for Business, have you heard ever?
No, sir.
Yeah. So, Teams, we are nowadays using Teams, right? So, Teams is successor of Skype for Business. There was Skype, then there was Skype for Business, okay? And then there is Teams. So your generation won't know Skype for Business existed. So I worked on that applications from scratch, okay, when it was there. So Skype for Business was similar to Teams. So we had on-prem infra for that, on-premise infrastructure. So and since it was Microsoft product, of course, they uses all the Windows servers, okay. So there was, a time when we used to reboot servers manually. Manually, can you imagine? We log into the server and reboot it. We did that sort of work as well back then because the server is not responding and it is stuck in reboot. It is doing something because the patches got auto installed or because of lot of reasons. Okay, we had redundancy back then as well. If one is down, other will take over. But still, I'm telling you the difference. But Linux server, on the other hand, could go 6 months without a reboot. Okay, that was the capacity it brought into picture, and that's why it became popular. And of course, open source in nature. Another thing, now I would say why these two things don't matter much. I will explain you that perspective also. Now, uh, infra is on cloud, okay? Be it any sort of cloud, okay? Be it GCP, be it Azure, be it AWS. What is happening now? There is Windows system, there is Linux system, okay? Let's say you have a Windows system and you have an application deployed on it, okay? Your web app deployed on it, and same Linux system. But now, since it is on cloud, it is containerized application. It could be containerized, right? It could be on service fabric. It could be microservice based. Anything be it. But who is taking care of it? Cloud provider. If you opt for correct service. So in the end, patching has gotten automatic for Windows. Everything reboots are happening automatically. You won't even notice what is happening in the backend. So that is the beauty cloud has brought into picture nowadays. So it really doesn't matter. If we consider some other factors, of course, there are some more differences, which I'm not going into right now. But just to give you overall, a view about it, a neutral point of view for Windows and Linux. Since the topic came, of course, it is not the point of our syllabus, but I just thought of bringing it to light so that we have some healthy conversation over here. So, anyways, are you clear what is RTOS and what is our general purpose OS and what are the differences? I take it as yes. So, RTOS, the key concepts we have, then we have importance in embedded system, these 2 points, but we are already past our time, right? What is your schedule for the day? I'm stopping the recording.